Is that right？ 得唔得 ？OK， 我要求好低嘅啫，唔好將兩個 density 相除，我已經覺得好好噶啦。唔好試話真係有啊，真係有兩個相除。OK， 我幾肯定佢應該頭嗰2年應該冇上過堂咁滯嘅。兩個 density 相除 ，alright， 記住唔好咁做啦，得唔得？有冇問題 ？So the whole skeleton is exactly the same as deriving the f, deriving the beta, and everything else I just did the same. Okay, but before that, I know you guys perhaps found a hurdle, and that's why I try to put the marks, try to reduce it as much as possible. Okay, I try to take this into account at a rather lower portion. Okay. Now, how about the other one, x1, x2? Now they are independent variables, and the PDF of each of them is as follows: just exponential, e minus x. Now this time, 好啦，咁呢條啲人會點咧？如果有啲人唔識做嘅話，佢會錯成點咧？咁同頭線上邊一樣，兩個相除，今次咧就將兩個 density 相減。Okay, all right. So for sure, it's completely nonsense, right? Okay, so we have to work it out one by one as before. So I try to show that to you. This is a rather canonical exponential distribution, and you have to find out the PDF of the difference of these two guys. All right, so how to find that out? OK， 咪有冇問題先？頭先嗰度 ，O 唔 OK？OK 嘛 ？OK， 我繼續。OK, the second part 2b asks you xi follows exponential distributions, and now the parameters is 1. Okay, and as before, first step, we want to find the CDF. Okay, find the CDF. The probability that x1 minus x2, I call this to be z, x1 equal to x2, probability z less than small z is equal to this guy, less than or equal to small z. Okay. In other words, it is just the same as probability x1 less than or equal to x2 plus z. Okay. All right. Now, this time, perhaps it's better for us to find something different. I try to write 1 minus probability x1 bigger than or equal to x2 plus z. Okay, in this way, apparently it's better. Okay, bigger. It's more convenient. I'm not claiming that it is a must, but it's more convenient. Why? As we are dealing with the exponential distributions. Okay, apparently, using this expression seems to much easier to be computed. So we have 1 minus, keeping the same thing, and now we're integrating all possibilities of x2. Okay, from 0 up to infinity as you expect. And now we would like to compute probability of x1 bigger than, I use small lecture now, we have x2. Maybe I try to put it this way, step by step. Okay. x2 plus z as before, but now given that x2 is equal to small x2 times the density of x2 times x2 dx2. Okay, law of total probability. Okay, in a continuous version. Now, maybe you would say, I never heard about that. You can still do the same and try to rewrite this guy as a double integral as before. But I would like to provide an alternative approach to show you that is not a must. Okay, so we can rewrite it as a law of total probability. I came across this during the lecture already. Law of total probability. Okay, law of total probability. Now, how to do? this is the density functions we already know. But we know that this guy, x2 and x1, they are independent. Okay, the only difference is we know now x2 is equal to small letter x2. So it would be the same as replacing this capital X2 by small letter x2. Okay, and then by that time, this event is actually totally independent of x1. So in other words, this conditional probability should be not different from an unconditional probability. Okay, so that means we have 1 minus integrating from 0 up to infinity as before. But now we're probability x1 bigger than x2 plus z, and together with this guy. Okay, so here is what we got. All right. Now, what this guy? It is exponential minus x2. And how about this guy? Okay, how about this guy? The tail probability, the right-hand tail probability of exponential random variables. And for sure, it is just e to the power minus. That's the same thing. x2 plus z. This is the argument. Okay, so we just plug it in. So we have this guy. Okay, that. Okay, 咩點解要咩 ？Sorry， 點解要咩 x2 我聽唔清楚，定係我耳鳴 ？OK， 明唔明？呢度有冇問題？得唔得先 ？OK， 啊，我相對性熟啲，所以寫啲嘢出嚟就 summarize 咗噶啦。OK， 就費事寫咁鬼多啲無謂嘢喺度。呢度已經簡單啲講，呢條題目咧已經驚你哋嗰啲 theta 咧，如果擺咗 theta 喺度咧，都驚你亂啊，俾個1你 ，OK， 都費事你錯啦，減少啲你哋會錯嘅機會 ，OK， 得唔得？呢度有冇問題先？去到呢度為止。Is that alright? Should I carry on? Can I carry on? Alright, so we carry on. If we plug in, here we got 1 minus integrating from 0 up to infinity. We're combining similar terms. Okay, combining similar terms. So here we got e minus 2x2 minus z. Okay, dx2. And for sure, this guy, we can integrating from 0 up to infinity. Extracting the minus z term here. And then we have e2x2 dx2. Okay. All right. And for sure, if we try to normalize this exponential, we multiply 2 and dividing by 2. This guy is actually integrating a density function. So it becomes 1. So the answer is 1 minus 1/2 z e minus z. Okay. And then we carry on, blah, blah, blah. You can find the PDF. Okay. But bear in mind what I enforce here is z. Z here is bigger than 0. Okay, it's bigger than 0. I talk about this small letter z. Is talk about z is bigger than 0. Okay, and actually we have the other half. By symmetry, we actually see the distribution. You can see the density function looks a little bit strange here. Where is it? Okay, if we try to differentiate this guy, now let me write it down. So x1 minus x2 less than or equal to z. Okay, apparently we have 1 minus half e to the power minus z. Okay, apparently, but actually we are talking about z is bigger than 0. We haven't yet talked about z is less than 1. The density function is actually symmetric around the 0, and it is symmetric in this way. Okay, and each of them is equal to 1/2 e to the power minus z. This is the density function. So we have 2 half here. Okay, and for this distribution, actually got a name. It is called Laplace distribution. Okay, and this kind of distribution, I would say, is quite important, especially if you guys would like to look for horse racing。OK， 如果你跑馬嘅話咧，呢、個 distribution 幾好用嘅。OK， 估啲賠率嗰陣時咧，你就唔會用 normal 嘅，會用呢個 Laplace 嘅。OK， 當然係我同事話俾我聽㗎啦。OK， 得唔得 ？This is Laplace distribution. We have positive and negative values. OK， 錄咗音啲大鑊。OK， 不過啲人都冇聽到咁後，得唔得？得唔得 ？O 唔 OK？好啦，就係咁，呢條相對性最難㗎啦。